For centuries, we've studied the sun, our star, our source of life, and our greatest celestial mystery. We've mapped its sunspots, tracked its flares, and even predicted its storms. From ancient astronomers to cutting-edge space telescopes, humanity has always looked up, trying to understand what fuels this enormous ball of plasma. But despite all our progress, there's one part of the sun we've never truly seen: its poles. Until June 2025, no spacecraft, no telescope, not even NASA or the ESA had ever captured detailed images of the sun's north and south poles. These regions have remained completely hidden from view, locked away by the laws of orbital mechanics and the dangerous conditions of deep space. Why does that matter? Because the sun's poles are more than just blank spots on a map. They're the birthplace of something far more powerful: its magnetic field. Every 11 years, the sun goes through a complete magnetic flip. North becomes south, south becomes north. This isn't just some minor shift, full-blown reconfiguration of the sun's entire magnetic system. And when that magnetic chaos spills over into the solar atmosphere, it can lead to violent eruptions, solar storms capable of disabling satellites, frying electronics, and knocking out power grids on Earth. In short, the poles are where the sun's most destructive forces begin. And yet, we've been flying blind. From Earth, we only ever see the sun from the side, along its equator. Even space telescopes like SOHO and SDO orbit in the same flat plane. It's like trying to understand a spinning globe while only looking at its waistline. The crucial top and bottom, always tilted away, always hidden. This frustrating blind spot has haunted solar physicists for decades, because while we could guess what was happening at the poles, we could never be sure. And in science, guessing isn't enough. But everything changed in June 2025. That's when a daring spacecraft, Solar Orbiter, finally tilted the odds in our favor. After years of travel and a complex series of gravitational slingshots, it reached a vantage point no human mission ever had. And from there, it looked directly into the unknown. What it captured wasn't just a blurry snapshot, it was a window into a part of the sun we had never seen before. And what it revealed is rewriting everything we thought we knew about our star. To see what no one has ever seen, you need more than ambition. You need the perfect machine, the perfect timing, and a plan decades in the making. That's exactly what Solar Orbiter is. Developed jointly by the European Space Agency, ESA, and NASA, Solar Orbiter isn't just another satellite. It's one of the most advanced solar observatories ever built. Designed to get closer to the sun than any mission before, without burning up, it had a very specific goal: reach a position high enough above the sun's equator to finally see the poles. But that's easier said than done. The sun is a deadly place. Temperatures in its vicinity can soar to over 500 degree Celsius, and radiation levels are extreme. To survive, Solar Orbiter had to be built like a fortress. A titanium structure with heat shields, radiation-resistant electronics, and solar panels that tilt away from the sun when they get too hot. But surviving the heat was just the beginning. The real challenge: getting into the right orbit. You can't just fly straight to the top of the sun. Space doesn't work like that. So engineers came up with an elegant solution: gravity assist. By swinging past Venus multiple times, Solar Orbiter gradually shifted the angle of its orbit. Each flyby gave it a tiny push, tilting its trajectory just enough to climb above and below the solar plane. This slow, spiral ascent took years, but it was the only way to escape the flat orbital path shared by most planets and spacecraft. Launched in February 2020, Solar Orbiter began its long journey toward the sun. Along the way, it sent back stunning images of the solar surface, observed magnetic field fluctuations, and even flew through the solar wind itself. But the real prize came in June 2025. After 5 years and multiple gravity assists, Solar Orbiter finally reached a high enough latitude to glimpse the sun's poles, and it delivered the first detailed images ever taken of these regions. The results were breathtaking. Instead of calm, frozen zones, the poles appeared alive, twisting with magnetic structures, streams of plasma, and signs of a massive magnetic flip already in progress. What made this moment historic wasn't just the images, it was what they represented: proof that we now have the tools to explore every part of our star, even the parts we were never meant to see. Solar Orbiter is expected to keep climbing in the years ahead, reaching even steeper angles, providing better and better views. Each orbit will unlock new layers of solar behavior, new insights into space weather, and possibly early warnings of the next great solar storm. But now that we've seen the poles, one question remains: what exactly is happening up there, right now, inside the heart of the sun's magnetic engine? At first glance, the poles of the sun might not seem like a big deal. They're just the top and bottom of a giant sphere of plasma, nothing more than 2 regions among millions of others, far from the violent flares and sunspots that rage across the equator. But that's exactly the mistake scientists used to make, because hidden beneath their quiet appearance, the solar poles are the nerve centers of the sun's magnetic engine. They're not just important, they're the very place where the solar cycle begins, evolves, and eventually resets itself. Every 11 years, the sun undergoes something remarkable: a full magnetic reversal. The north and south poles swap places, not physically, but magnetically. This isn't just a minor fluctuation, it's an event that reconfigures the sun's entire magnetic field. And that field is what drives nearly everything the sun does. When magnetic lines twist and tangle near the surface, they can suddenly snap, releasing explosive solar flares or coronal mass ejections that shoot billions of tons of plasma into space. These outbursts can travel all the way to Earth, disrupting satellites, navigation systems, power grids, and even exposing airline passengers to increased radiation. But here's the key. The seeds of that chaos are planted at the poles. It's in those regions that the magnetic field plunges deep into the sun's interior, where it is stretched, amplified, and eventually flipped. The poles act as gateways, connecting the sun's surface to its mysterious magnetic core. And during a reversal, those gateways become unstable, turbulent, and incredibly active. If we want to understand space weather, we need to understand what's happening at the poles, because until now, we've only been observing the effects, watching ocean waves without knowing what causes the tides. The poles are the hidden gears behind the whole mechanism. Even more fascinating, the polar magnetic fields appear to weaken before each flip, almost like a pause before the entire magnetic structure collapses and rebuilds. It's a brief window of instability that might explain why certain solar cycles are more violent than others. And that's not just academic. In 1859, the infamous Carrington event sent a solar storm so powerful it set telegraph stations on fire. If that happened today, experts warn it could cause trillions in damage and take down entire sections of the power grid for weeks or months. Being able to monitor the poles in real time to detect early signs of instability could be the key to predicting and preparing for the next major space weather event. The poles aren't just ends of a sphere, they're the origin of every solar cycle, and possibly of the next global blackout. Most people think of the sun as something distant, untouchable, a ball of fire that lights up the sky but has little to do with their daily lives. They couldn't be more wrong, because while the sun sits 150 million kilometers away, its influence reaches right into our power sockets, our phone signals, our satellites, and even the cockpit of planes flying above your head right now. This invisible connection is known as space weather, and when the sun gets angry, the consequences can be catastrophic. It all starts with magnetic chaos. When the sun's magnetic field becomes unstable, especially during polarity reversals, it can unleash solar storms, massive eruptions of energy and particles that travel through space at incredible speeds. Some storms carry coronal mass ejections, CMEs, gigantic clouds of plasma, and magnetic fields hurled toward Earth. When these CMEs hit our planet's magnetosphere, they can cause geomagnetic storms. These aren't science fiction, they're very real, and they've happened before. In 1989, a solar storm hit Earth and knocked out the entire power grid of Quebec, Canada. In just 90 seconds, 6 million people were plunged into darkness. That same event caused satellites to malfunction and disrupted shortwave radio across the globe. And that was just a moderate one. The real monster was the Carrington event in 1859, the most powerful solar storm ever recorded. Telegraph systems across Europe and North America burst into flames. Auroras were seen as far south as the Caribbean, and compasses spun uncontrollably. If a similar storm hit today, it could disable GPS networks, cripple satellites, and cause massive blackouts affecting entire continents. The economic damage, estimated at $2 to $3 trillion, with recovery time stretching into months or even years. And here's the scary part. These storms are not predictable. We can detect them once they're on their way, but that gives us only minutes to hours of warning. By then, it's often too late to protect the delicate systems that modern life depends on. Satellites, aviation networks, internet cables, electrical grids. But what if we could see them coming? Days in advance. That's the promise of Solar Orbiter. By observing the sun's polar regions in real time, we can start to identify the early warning signs of magnetic instability. We might even be able to detect patterns, shifts in magnetic field strength, strange plasma flows that signal when a massive eruption is building. And this is more than just scientific curiosity. It's about protecting the infrastructure of the 21st century. From banks and hospitals to planes and power plants, everything depends on timing, connection, and electricity. The next global blackout may not come from a cyber attack or natural disaster. It may come from the sky, and we may only have a few minutes to stop it. Solar Orbiter has given us something extraordinary, a window into the sun's magnetic heart. At the very moment, it's reshaping itself. For the first time, we're not just reacting to the sun, we're learning to anticipate it, and that changes everything. For decades, scientists have tried to predict the solar cycle, the 11-year rise and fall of solar activity. When it peaks, the sun becomes a storm factory. When it falls, it enters a quieter phase. But the exact timing, strength, and behavior of each cycle has remained maddeningly difficult to forecast. Now, thanks to the polar data collected by Solar Orbiter, researchers believe they can finally refine their models. By monitoring the buildup and decay of magnetic fields at the poles, they can begin to spot the signs of an approaching flip or even estimate how intense the next cycle might be. And that's more than a scientific curiosity. It's a shield for Earth. Imagine being able to issue multi-week warnings before a major solar storm. Power companies could protect the grid. Satellite operators could shut down sensitive systems. Airlines could reroute flights to avoid radiation exposure. Even astronauts on the International Space Station or future Moon and Mars missions could take cover in time. What's at stake is not just communication or convenience, it's infrastructure, defense, transport, finance, the entire digital nervous system of modern civilization. But Solar Orbiter is just the beginning. Its data is now feeding into an entire ecosystem of research. Ground-based solar telescopes like the Daniel K. Inouye Solar Telescope, DKS, NASA's Parker Solar Probe, which dives into the sun's outer atmosphere, AI-powered space weather, prediction systems trained on new polar observation. Together, these tools are helping to build a real-time solar warning network, a kind of cosmic early alert system that could, one day, protect billions of lives from the sun's next outburst. Solar Orbiter continues its mission, slowly tilting higher, orbit after orbit, unlocking new perspectives with each pass. And scientists are already looking ahead, designing future missions with even steeper inclinations, deeper dives, and more precise instruments. Because the more we learn about the sun, the more we realize it's not just a source of light, it's a living, changing force, capable of shaping the future of life on Earth. And now that we've seen its hidden side, we must ask, what else has the sun been hiding? We've always looked to the heavens with awe, but maybe we haven't looked closely enough. For centuries, the sun has been our ally, giving us warmth, energy, and life itself. But it also holds the power to disrupt everything we've built: satellites, power grids, air traffic, communication systems. And until now, we were watching it blind, missing the most critical part of its magnetic machinery. Solar Orbiter changed that. By revealing the poles, we've unlocked a new chapter in solar science, a chance not just to understand our star, but to predict its next move, to prepare, to protect, and maybe even to prevent disaster. Because the most powerful force threatening our modern world might not come from within. It might come from 250 million kilometers above us, wrapped in magnetism, pulsing in silence.